Hi, in this video I'm going to talk to you about bug hunting, the way that you can find errors in programs and maybe make some money. So the science of bug hunting really uses some pretty fantastic tools and is basic computer science. So the motive for most people is money. You can see that there are 3 different companies set up on this slide here that offer cash rewards if you can find a bug in a significant piece of software. So a significant piece of software is not my program that I created for this class, but it is probably something more like the Chrome browser or Microsoft Word or the Internet Explorer, something that is widely used, or maybe something that's embedded in a Cisco router. It is a security flaw that would be of major importance. And so, what are the tools that you would use and the techniques if you wanted to gain some money in this game? So most of the people that work with these bug hunting tools use a process called fuzzing. So fuzzing is, as you can see in this example, a program that will input invalid data into what is expected. And so it could be a simple number that is close to the real thing or completely random. Now, people don't sit there and type these things out by hand. They have programs that do it for them. And it's an automated process of finding hackable software bugs by randomly feeding slightly different permutations of data into the target until one of those things reveals a bug. For example, if I had a program that asked me, please put in a number from 1 to 100. We've all written software that says something like that. And you put in a 50, of course, if you're trying to do the right thing. Now, you might try a 0. That's an edge case. Or you might say, hey, they didn't ask about negative numbers, did they? And you could try it out. Or you might put in a wrong data type, such as a decimal. Or you might put in a space plus your number. Or you might just put a space in the middle of your numbers. You get the idea. We put a comma in, or we might not put numbers at all. We just put in some text, or we put in a letter O where the 0 once was. Or maybe we don't put any input at all, or we put in a really big number, or maybe we put in some kind of a hex string. The idea is that when you are randomly throwing numbers at a program, it's sometimes called monkey testing. And the idea that the monkey at a keyboard can generate random input. And so literally it's either you put numbers into an input as a text prompt, or you would literally simulate random touches on a cell phone. Monkey testing will try to get all of those cases if you can do it long enough and with enough randomness. Of course, the figurative monkey is the infinite monkey theorem, sometimes said that if you had a number of monkeys with infinite amount of time, that eventually one of them would type out the entire works of William Shakespeare. Well, we've kind of disproved that. Well, with the number of decades now that we've been on the internet, there's a lot of monkeys typing, and nothing as good as Shakespeare's works has seemed to have come out yet. So the original monkey program was actually a tool that was developed for an early version of Mac Paint. So a Macintosh program that is kind of the precursor to Photoshop, and it was designed to test for random inputs. Now, intelligent monkeys and dumb monkeys are both here in the game. So an intelligent monkey is an actual piece of software that is used to do intelligent fuzzing. So it's not just randomness, but it's slight one-off things or malformed text. So let me show you a program that is a good example of one of these monkey testers. So Radames, or Radames you might call it, is available for free on GitHub, and you can compile it and run it on your program of choice. So let's go through these steps here to get this thing installed, and then I'll show you how it works. So we're going to follow this part here called Building Radames. I'm going to copy the first line that they have given us, and I'm going to paste it into my terminals. I'm using a Macintosh. And this first command gets the information, literally gets it from GitHub. So it downloads the program. Then we do a change directory to get into the place where we just installed it, and then we type the word make. So make is the process of compiling all of the code that they gave us. And so this will work differently on a Windows computer than it will on your Mac or on your Linux computer. And so this is the process of just copy and paste it from their instructions. And then when we're done here, we're going to have the ability to do an install. So this is a long statement. I'm going to just copy it and then paste it into the terminal and then watch what happens. So it does an install, and now I can choose the program command and type in --help, and that'll tell me if it's actually going to work. So if it worked properly, you will get a message that says how you can run all of the software on your program. Now, they provide some examples of how you can fuzz with Radames. So for instance, we could just type in an echo statement and a string and then tell it a pipe character to go through Radames. Let's see if we can do some examples. So let's bring up the prompt. So let's do an example that they show here, such as the AAA, and then we'll do a pipe character and then Radames. And you can see that the first result says, hey, I'm going to just double the characters. So let's do an up arrow and press enter again, so we'll get a second one. And you can see that this provided a whole bunch of A's, plus it looks like some blank lines. The next one, they throw in some question marks, they throw in some characters that aren't really printable like normal. We've got things that look like the original input at sometimes, and sometimes nothing at all. But you can see that if we were to make this an effective test, we would use this input for every character that Radames produces, and then we would see if our computer crashes or if we have good error checking. So let's try a little bit more sophisticated piece of data, such as some HTML. So I'll put in a span tag in hello world with a close tag. And then don't forget to put the pipe character and Radames. Now let's press enter. So you can see that it senses the HTML and it says, I'm going to put in a whole bunch of spans. And this one appears to be even bigger. And I would expect that somewhere along the line you're going to see unbalanced tags, where sometimes it opens the span tag twice, sometimes it closes it early. But if you ran this 1 billion times, you would eventually crash your program. So this would be a great way to test your browser to see if it's able to parse HTML correctly. Let's look at another example they have down here. So we are doing a number and a string at the same time. So let's copy that. And what do we get out of here? So let's paste and run. So you can see that it recognizes the string and it recognizes the integer as two different objects. So one of them is an integer that just keeps changing every time, and the other is more like just a string. Now, to run a program like this is obviously going to take some computing power. So we are going to run Radames or something like it, and we're going to run it thousands of times or maybe millions of times, and we're going to try generating random web pages and throw them into the target browser. And when all possible combinations of JavaScript and HTML are run, we'll check to see if the browser is able to handle it. So we'll let it run for a week, maybe a year, and we'll look through the blogs, and we are going to find, hopefully, a crash report. So why would we do fuzzing instead of designing input? It's because you can get so many actual results out of it in an automated fashion. So generating random data would take a lot of effort for humans. So the ultimate zero-day toolkit is to have a supercomputer. And fortunately, if you've got the resources and a few $1 million, you can buy your own. However, if you want to rent one, Amazon will give you enough computing power, or Azure with Microsoft. You can spin up your own servers, and with literally the resources of what used to be a mainframe, you can do it on your own. Now, what are we looking for? We're looking for crash reports. So there might be thousands, maybe millions of pages of data to look at. But what interests a bug finder? It's when you find an interesting bug, such as when you are able to see a buffer overflow or something that isn't quite right. Now, here is a good example. Let's say you are looking for the ability for a user account to change into an elevated privilege, such as an admin. And so we wouldn't test against the admin account so much, but we might try random logins on a regular user account, because anyone can get the regular user account to Google, but nobody gets the admin account. What we would hope for and get lucky is if there were an exploit that were able to turn my Gmail account into a admin account for Google. So what bugs have actually been found? Well, a number of years ago, there was this amazing bug that was discovered called shell shock. You can see that shell is the idea of a Unix shell, just like we were typing in earlier. It's the command prompt. And shell shock was the actual exploit. And what happened was that we were able to find that in 2014, we could get into Unix computers using a fuzzing program that was discovered, and a bug that had been in existence for 22 years was discovered. Well, at least it was notified to the public. Maybe it was discovered years before, and there were some hackers that were just gleefully using their tool for decades. Well, as soon as the information was released, as this is a vulnerability in the shell bash script, then we had a problem that just exploded worldwide. There were all kinds of vulnerabilities that were exploited. Now, companies such as Google are very serious about their security. They don't want their web browser with vulnerabilities. And so apparently, they continuously are using fuzzing programs with a machine that has 15,000 cores, and Microsoft Edge and the other programs that are using web browsers are using billions of HTML files, and they're trying to find a result like you see here, where your tab just crashed or something. Here's another tool that people would use, the American Fuzzy Lop. So that's an actual name of a breed of rabbit, so it's a great name for a tool that is doing fuzzing. Here's another example of Radames, and it is using little tweaks of data. So you can see that the first sentence says an engineer walks into a beer, and then it goes on from there. So different random cases are generated, and we just put them into an infinite loop and see what happens. Now here is an example of something that would be of an interest to a hacker. So we look at this code and we can see an executable bad access. So what is that code all about, and why is it important? So this means it's interesting because the program is now accessing a region of memory that no longer exists. So some deallocated piece of variable or string or something that the program used to have, and it's no longer allocated to that program. Now this is good because you can then insert data into that place where the program tried to access it, and then maybe you can run your own code. So for instance, the method says, hey, I want to get a hold of the variable called score. Well, score no longer is in memory, it's been deleted. And now the program crashes. It says, hey, nothing there to look at. So you can insert your own code there where score used to be, and then maybe that would be the code that would elevate your user privileges, or it would change the direction of the output, or something that would be more of a hacking tool. So if you substitute your own malicious code here, you've got the game won, and you have got yourself an exploit. So I'd like to refer you to a good video maybe on YouTube that would show you of a couple of people that explain the process in easy to understand terms of how they would use fuzzing, and then they would discover these vulnerabilities. So take a look at the link here. The first 30 minutes or so was probably the most instructive in my opinion, so check that out. So once you have discovered a vulnerability in code, this is what you're supposed to do. You're supposed to report it to the Common Vulnerabilities and Exposure Database. And this gives it a case number, it tells you exactly what's wrong with it. And that's the formal notice to the manufacturer of the software that they better get their game in order because it is vulnerable and their customers are going to get hacked. So this goes into a database and it's of course viewed worldwide. Now it's a good idea for companies to have an incentive for all these hackers to tell them about their discoveries. So if you discovered a way to get into a Cisco router and sniff all of the traffic and all unencrypted messages, how much would that be worth? Well, to the Korean government, it would probably be worth billions. And so Cisco would be willing to spend some money to fix that error before it was actually released to this common knowledge database. And so there are these organizations that have been funded from companies that are looking for you to earn some extra cash. Now, the problem is that these companies, although they promise they're going to pay you, in recent years, the number of people that have actually taken advantage and taken the money from the companies has gone down. Now, why would that be? It's because there are other people out there that are willing to pay more. So think all of the governments that would be interested in spying on US companies. So yeah, Russia, China, North Korea, anyone else that has got some kind of a game to play with us. Or you might think that the US government itself is interested. And so the NSA, the CIA, they might be interested to know, hey, I'll take some of those exploits. You don't have to tell Microsoft about them. We'll take it off your hands and we'll pay you a little bit extra, and don't tell anybody, because the only valuable exploit is the one that nobody knows about. So here's the process of how this zero-day initiative works. This is taken straight from their website. So the process says, hey, we discovered a problem, we submit the case, and then they validate it to say, hey, yeah, I think you actually do have a real exploit here. It's a significant item. It's to a piece of software that people actually use. And then we'll give you a reward. And of course, you can accept the reward, and if they do this process correctly, they will notify the vendor and they fix the problem, and consumers don't get hurt about it. So here's some guidelines from Zerodium in their what they're looking for. So for example, at the bottom of the page, you can see here that they're looking for operating systems, web browsers, clients and files such as Microsoft Office, and then smartphones. And so the usual things that everybody uses, we want to know where these exploits are. So you might have heard in the case recently that Apple and FBI seem to be fighting with each other all the time. And so the question is, should we give these items to the companies, or should we retain them for ourselves? So that's a great question. Should we notify companies and make their software more secure, or should the government itself keep them and maybe use it for their advantage? Now we know that the United States government is already playing the second part of the game. They're not telling Cisco and Microsoft and Google about their vulnerabilities. They keep them. How do we know that? Well, thanks to Edward Snowden and his leaks in 2013, they found a line item in the budget that the United States spent $25 million to exploit finders. So that was some time ago now. $25 million was then. Apparently the money is even better today. And of course, the governments that are after the United States are more aggressive than ever. So there's a story that broke the news some time ago that told us about an embarrassment that happened, I think it was with the NSA. So there was a group called the Shadow Brokers, and they broke into an NSA server that was literally like the gun case. It was the weapons storage bunker of their cyber tools. And so all of these exploits that the NSA could use to spy on people were themselves stolen. And so who knows what they were? You could get exploits that could get bank accounts, that could break into Windows 10 and take control of it, to use web browsers, routers, and smartphones in your own admin mode. All of this information was stolen and then sold. And of course it had a very short shelf life, because exploits, as soon as they're used or as soon as discovered and published, they are closed, they are fixed by the companies that own the software. And so there was a $64,000 monthly fee to subscribe to this service. And so we know what some kind of a value is placed on the black market for these things. Now, as I mentioned, Apple and FBI have been in the public sphere about this argument for some time. So there were a couple of shootings. One was in San Bernardino, California, and another one was in Florida at a Navy base, where in both cases there were shooters that killed people on the base. There was a clear law enforcement mandate. We need to find and solve this case. And in both cases, there was a cell phone from Apple. And the FBI said, hey, we want to look at the cell phone. We want to open that cell phone and see who the contacts are, see who the calls were made to, see if there's any pictures, see if there's anything of interest on that phone. And Apple said, we don't open phones. We don't cooperate with anybody, whether it's terrorists or the FBI. There is no backdoor to our phone. And the FBI was very angry. They said, we are law enforcement. We have an actual constitutional right to have search warrants, and you must cooperate with us. That is the law. And Apple said, sorry, we don't have that ability. We have not built the back door. And so FBI has hired outside hackers in some cases and paid millions of dollars perhaps to find exploits that will do the open phone process for them. And so you'll probably see cases in the future with the exact same players or maybe somebody else. But right now, the only way for the FBI to get into certain things is to buy these exploits and hire someone to do it for them. So how long does a vulnerability last in an exploit before it gets fixed? So does it last for a month? Does it last for years? As I mentioned before, there was a case where there was a 22-year-old exploit. How long do they live? So the answer to the question about when we should share this information or whether we should retain it really has to do with the question about us and them. So if we were to put a pool of bugs into the yellow side that said these are all of the publicly known vulnerabilities in software, and then the enemies, let's call them enemies, the them, they have their exploits, and then we have the us, let's say that's our good guys, that's the US government. And we don't know who has what and how much overlap there is between these different spheres. So if the question were, we have all of the same bugs that they have, if the overlap is very strong, then that would give a strong case to say we should reveal them. We should just get them fixed, and that way nobody gets to do the exploits. So that would be wonderful if we could just clear off this exploit problem once and for all. However, more than likely, there is a smaller pool of overlap. And so what we know and what they know is very little in common. If that were the case, then this would give us a strong incentive to not share and tell the world that we have problems with our software and it needs to be fixed. And so it appears that this second case must be what's actually happening because there are fewer exploits being reported. So here's another video that I would recommend for you. This is from the RAND Corporation that was doing some research into how long and how often exploits are reported. So this is a kind of a long presentation, so I will just let her take care of it and show you some of the interesting research on which kind of category we're playing in today.